Hi guys, today we're going to have a look at a couple more angle rules. The focus for this video is going to be looking at the sum of angles inside any polygon. We're going to start from where we know. We know about triangles will always add to 180 degrees. So if we've got these three, A, B and C, we can say A plus B plus C will always add to 180 degrees no matter what the size of those angles are, because angles in a triangle will always add to 180 degrees. That's the rule. Now we're going to use this rule to extend it to polygons that have more than three sides. So we should know that quadrilaterals or four-sided shapes will always add to 360, but we need to be able to work out 5, 6, 7 or as many sided shapes as we like. So we're going to use this shape as our example, and the way to do it is to join up any point, any one of the vertices on the shape with every other vertice, and that'll make a certain number of triangles. So if I start from here, and I've just picked that at random, you could pick any one of them, and then I'm going to join it up with straight lines. We've already joined to that vertice and that vertice, so I'll need one to there, one to there, and one to there. Now what we've got is four triangles, and what you'll see if we look at all these angles, all the angles that make up those four triangles, if you added all of those little parts together, they're going to give you the exact 6 angles inside that shape. So basically, to work out what the sum of those 6 big angles are, it's going to be the sum of those 4 triangles. And we know that a triangle adds to 180 degrees, so the sum is going to be 4 times 180 degrees. And that's going to work no matter what the polygon is. This was a 6-sided polygon. If we did a 10-sided polygon, then when we join them all up, we're going to have 8 triangles because of those first 2 already being joined. And that all comes together to give us a nice rule. So this formula will work for any polygon as long as you know the number of sides it has. Now how it works, we take the number of sides of the polygon, we subtract 2 from it, and then we times that result by 180 degrees, because that n minus 2 will tell us how many little triangles we can break that shape into. So when it comes to working this out in a test, you can either do it triangle way, or you can do it formula way. No way's right or wrong. They're both right. No way's better than the other. They both give you the same answer, and as long as you show you're working, you're going to get it right in a test. The next part of this is we're going to extend this to regular polygons. So again, this is something that we should know, so I am going to rush through it, and just make sure you ask for clarification in class if you're not sure about any of this sort of stuff. But the thing about regular polygons, it's a polygon where all sides are equal in length, but also all angles are equal. So that means if we know we have a regular polygon, we can work out the size of each individual angle, whereas that doesn't apply for a non-regular polygon because each angle might be a different size. So if we wanted to find out the interior angle of a regular polygon, then we can use the same rule, n minus 2 times 180, and that'll tell us the sum of all of the angles inside the shape. And because we know all the angles are the same size, we can divide that by the number of sides there are, because the number of sides is the same as the number of angles. So I'll just show you that with an example, and we'll keep it pretty simple. We'll do a regular pentagon with 5 sides. Now that looks pretty close to regular, but we can do something like that just to indicate that it's a sketch and it is regular. So if we wanted to know how big each angle was inside this pentagon, if we just label one of them x, we could say that x equals n minus 2 times 180 degrees divided by n. In this case, because it's a pentagon, it has 5 sides, so n equals 5. So what we get is 5 take away 2 times 180, all divided by 5. 5 take away 2 is obviously 3. And that there is something that we can chuck into our calculator. You don't really need to see the screen this time, so don't worry if you can't. And that tells us that each angle inside any regular pentagon is going to be exactly 108 degrees. So just to quickly summarize, we've just done one rule looking at the angles inside any polygon. We can base it on breaking the shape up into small triangles, or we can use the rule n minus 2 times 180 degrees, and that will, both ways will work for you every single time. So have a look again on My Maths. There is a corresponding homework set, so get into it and I will see you in class.